of the fluid. So instead of going this way, it goes this way. And by inventing coils, there can be either or. So for part of the year, that coil is a condenser. For the other part, and the other one is an evaporator. For the other part of the year, they exchange duty. They can do it.
So coils have to be used both ways, what you're saying, right?
Yep.
And so it's called a reverse cycle heat pump, and that's both air conditioning and it's for heating and cooling.
You're always based on change of phase. When the change of phase goes in one direction, it sucks heat. When it goes in the other direction, it releases heat. It absorbs heat. So the VCC device is going to be there. You can put it this way, or you can put it this way, and that's it. The heat pump automatically does this, depending on what you want. You want heating? This way. You want cooling? This way. But it doesn't move anything. It just changes the direction of the fluid. And by changing the direction of the fluid, the evaporation now goes to the other coil, and the condensation goes to the other coil. Okay, typical outside unit. Now, this is this guy is going to go up to 45,000 BTUs now. It's going to be a little bigger than this, so this guy is going to be smaller.
6,000 square footage, what would it cover? 1,000, 2,000? 1,500?
6,500, 400, 6,500 BTUs, 400. So this guy probably will take three regular size rooms.
Well, less than 1,000.
But if you buy the big one, the big one goes up to 45, 48, something like that. They can run 9 rooms. The multi-splits today, 45,000 BTUs, 9 terminal units. Obviously not immense rooms, regular size,
10 by 12 rooms.
something like that. Okay, so this is a geothermal. You stick it in the water, you stick it in the ground, and you have, you're not dealing with temperature of the air coming and going, between the winter and the summer and so on. You got practically 50 degrees more or less stable temperature. You dig deep enough that you go up to stable temperature, and that's the ideal, because if you're around 55, 57 degrees, you're right in between heating and cooling. So you can reject easily, you can absorb easily. PTACs, hotels, motels, under the window, hole to the wall, sitting on the floor, because these guys are heavy. They started by being VCC devices or fan only, right, for air circulation. And then they put in an electric coil, so they became also heating, but hybrid. VCC for cooling and electrical coils for heating. Nowadays, it's all heat pump.
You're not gonna believe this. There's curtains that when you close the curtains, you're closing that. So that's the sense of having curtains.
But we know better.
You gotta know. You gotta
We use
put
only the curtains in the window,
It's just the
not the
word.
big ones. Okay? These are industrial grade. There's no cheapy stuff of this kind. Okay? Problem with these guys, you have, if the hole is not there, 42 inches hole, standard in the industry. Bunch of codes and so on. I'm not going to allow you to put a hole like that in your existing building. So that's the problem. I had a customer that insisted that they wanted PTAC units through the window. See, through the window, 120 pounds, so 42 inches wide. Okay, they don't go very far. 19,000 BTUs. It's a very large room, or maybe it's a suite in a hotel or something, right? A couple of rooms. But they are strong, man. And then you get all these modern controls, where especially if you put a remote thermostat and so on, you can do whatever you want. You can program and resets. I mean, I'm not in now through your phone, right? wireless. Oh, I'm going home and it's earlier than usual, so I'm going to override the regular programming, and I'm going to tell this guy start now because I'm going to be home in a half hour. All right, these are the regular multi-split that you see. This could be, no, there are only three. Oh, well, yeah, 3 units. That's probably a large, a small residential with 3 apartments or something like that. But if you have smaller buildings, they started taking all these condensers for the lower, I mean, you have a number of floors, so we cut in half and put these condensers on the floor on the ground for the first several floors, and then take everything out to the roof. This is unitized, so every apartment's got its own, and you can have it. And these are the indoor terminal units, now up to 9. Right? But these guys must be the most powerful that you can get, but you can go up to 9.
When you service these, you service them obviously from the view that we're looking at, right? Because I've had these installed on a roof in West Village 2 years ago, and the code was it had to be 3 feet away from the wall. So why? You have to service it from the back? Why don't they just service it from the face or the part that we're seeing?
I'm in the process of putting permanent anchors on my roof because I have to repoint my chimney and it's over 30 feet in the air, so I don't want to fall over there. So I used to be a rock climber. I know you have no idea the regulations about the anchors on the roof.
They gotta be
6 feet away from the edge, because so if you fall, you don't swing and you don't.
and it's gotta be welded to the structure. You know?
No, not welded, but you have to
How's it
find
gonna be bolted?
Yeah, it's done so, but you have to get a rafter. So now the problem is how to.
Steel rafter. Beam.
No, the house is 100
Wood?
years old. So I have to find the rafter.
Oh man. Okay.
And the only way to find the rafter is to remove the peak tiles.
Wow.
And then you see where the panels get together, so that's where the rafter is, right? So I'm waiting for the rain to stop because I don't want to go on the roof. I mean, my roof is 45 degrees, so you can barely stand on it. Right?
And you're gonna put your condensing unit?
No, I have to
Sure.
repoint the chimney. I
Oh,
have a
that's what
big
you have to
chimney
do.
with 3 flues,
Ah.
and you can almost see through them. Wow. Because it lost all the motor, so I have to go there. It's like, and all my friends say, maybe you should pay somebody else. Yeah, sure. Pay somebody else. What am I, dead?
No, you're gonna take them to Disney World. That's how much money they're gonna make.
Well, going back to PTAC, with the compressors are outside, right?
Yeah.
Can you,
No, it's not really outside.
it's not,
PTACs are one unit.
but outside.
It's like the to the window.
Yeah, I know, but outside, it runs
Those are
out
multi-splits.
to splits.
Yes.
What's outside is the condenser. Talking about that fan.
But he said compressors are outside.
Yeah.
Yeah, the fans, exactly.
The compressor is always outside because it's noisy.
And also, isn't compressors, when it compress, it releases heat, so it releases the outside?
Not a compressor. The condensing
Condense.
coil.
That's right.
Now that condensing coil is not a condensing coil anymore. It's a condensing or evaporator coil.
So,
Because now we have a heat pump, so you can do either. But the compressor, you want to throw it out anyway because it's noisy.
it's nice. So
So you don't want it in the house.
technically the PTAC is also a reverse cycle heat pump?
Nowadays, yes. Now they are heat pumps. So they do heating, cooling, and ventilation because you can go fan only.
They even call them just heat pumps. When I googled heat pumps, I see PTACs.
Yeah, a P-tank was practically the design of the thing and, you know, the shape and work, but. Okay, so, few words about this quickly. The mechanical mixing valve, right? If you have anything that generates your domestic hot water, it's gonna be more than 120 degrees. You're gonna go up. If you have any storage, you're gonna be 140 or higher. so you don't want to grow little animals in there. You cannot release the water to the building at that temperature. It has to be 120 degrees by code. So it has to go through a valve. Check the valve, 3 connections. 1 input, 2 inputs, 1 output. Hot water input, drinking water, city water input, and tempered output or mixed output. The mixed output can go up on 125 degrees. They will let you because then along the way you can lose a couple of degrees, but the magic number is 120. Okay, if it looks that simple, there's a question. They'll show you the picture. There's a mechanical mixing valve, not a manual mixing valve, a mechanical. The other one, sophisticated with electronics on top and so on, that's an electronic mixing valve. There are other valves that look a lot like this one, but they are not mixing valves because they don't have this. Mixing valve, 3 connections. All right, you can have automatic valves on the different zones of a building for water or steam. That depending on the thermostat and so on, with open and close the amount of water or steam that can go to the individual zone. But they will be in line with the pipe. These guys have 3 connections, right? Indirect, you see it, the boiler is producing the hot water and then it goes into a coil in the tank. The tank is just a tank, nothing else. Alright? So indirect. The tank is not producing this heat. This is static, this is for you. Independent domestic hot water. Now this is the domestic hot water heater with tank. The water can be heated electrically, there's the one to the left, or fuel, which is practically a small boiler at the bottom,
Yes, right.
right? If it doesn't have anything at the top, there's no venting, that's electric. Either electric or indirect.
Indirect
Just check if there is a connection to the
Right.
boiler.
to the outside.
So if there is a connection to the boiler, it's indirect. If there's no connection to the boiler, it's electric.
What's the one that goes to outside? Something went outside. Yeah, and there was like a blow dryer connected to it. Something
Where?
else. I don't know what it was. Had like a fan connected to it. Mechanically push the air out.
It's important when you here with the gas guys. I mean, there are no oil powered fire. There's all gas, natural gas, right? You have to do combustion safety, so you have to check for CR in company at the very top, right? This is between us. Check for leaks. You have water leaks on top and rust. That's gonna tell you. It's either whitish deposit, that's the limestone in the water, and it's just straight water leaks, or and the rust is the consequence, right? So that's one bad thing. In terms of checking the exhaust pipes, they have to be slanted upwards, right? If they are like this, what's going to happen? You're going to have a little bit of condensation or something. Water is not full here. You're going to have rust and a hole there. So they have to be slanted upwards. What? A 1/4 inch per foot.
God, something.
Any contractor that doesn't install that properly is a no.
I found, so I can show you pictures of venting for boilers or these guys, and then holes this big. External steel venting pipes. When it ends and then it changes direction and it goes into the boiler room, right? Holes this big,
Because the
practically
water
open,
it builds up and it
rusted
rots.
out. All right. PNT safety valve, drainage 6 inches from the floor. What else do you have there? These are industrial kinds. They are monsters. You can heat up a house with these guys. They do in some places. I mean, you can use a domestic hot water heater of this kind, right? 715,000 BTUs per hour. That's 8 apartments, 7, 8 apartments.
Wow.
Yeah. A regular house is 100,000 BTUs. Monsters, okay? Now, gas fuel combustion, 93% efficiency. Now you see something different. You see guys that look like this, so they look really, well made, and then the top, they have an additional growth. That's a heat pump. So they are heat pump based now. They cost money, but efficiency, tremendous. And the last thing, these are tankless. This building is usually tankless. They're small. They're about this big. So no tank, on demand. You turn on the hot water, these guys are going to turn on. They can be gas, they can be electric. Electric is always very clean and so on, but it costs you money. What's the problem? There's no water capacity because there's no tank, no nothing. So you got only the capacity of the heating capacity of the thing, right? So these guys can typically take a shower and maybe a faucet, and that's it. If you want 2 showers to run at the same time, you need 2 of these. So there's very little heat capacity, and then the other problem is the temperature rise between the city water goes in and the hot water comes out. If you look at the specs here, (100 degrees temperature rise. So if the city water comes in at 50 degrees, you can have hot water coming out at 150 degrees. The little guys is 60 degrees. So not only you don't have volume, but also you can heat up the water only to a certain level. For some applications that are ideal, in places like this, where you don't need volume and so on, where people just wash their hands. Okay? Thank you for your attention.
Thank you. Yeah,
This
I
stuff
have to
that we
call
look at
the
was by
professor.
far the most important thing to review.
The tankless water tank. I mean, the tankless water heater. I had to call the professor and basically take a picture and ask him, what is that? And he told me that, but there was a word he used. Do you know what else they call those?
They're called tankless, they're called on demand, and they're called instantaneous.
That's what instantaneous boiler?
No, water heater.
Water heater. Instantaneous water heater. I remember that. That was the
Yeah.
word.
Thank you, Marino. Appreciate
You're
it.
very welcome. And